I'm trying to get logged in to everything. Stand by. Oh, for crying out loud. Okay, you're just gonna have to give me a minute. I'm just unable to log into the chat at the moment. So just stand by, just relax. Hopefully you can hear me. 1, 2, yes you can. Just give me another minute. Thank goodness for that. Right, I might be in. Okay. Good evening. I might just assume that that's all working now. Oh, thanks, David. You've been looking at the merch. Good lad. Well done. Okay. Get myself together. Right. Welcome to this evening's soldathon. To this evening's Erica Synths DIY case and power supply. That's where we are. So far, we've built the dual VCA and the VCO. Let me just use a visual aid here. Why haven't I plugged that in yet? I mean, hang on. I need to put just a couple of screws in, I think would be good at this juncture. Video and sound are good, thank you, I appreciate that, that's very useful. Behringer Synths need to supply USA adapters. Yeah, I would say so. I think that's common, isn't it? To put everything in. But then if you're buying from Europe, you know, it's not always a given. Thanks, Ken, all working. I was going to ask you earlier, Ken, actually, if you could recommend what sort of wire I'm going to need with this, because I think that's going to be our issue for the evening. Anyway, there we go. This is not the case. No, this is a Moog case. Look at that. These are the modules we've done so far. The VCO, the oscillator, and the VCA. They've also got the envelope out, which I hope to tackle next week. But I was umming and ahhing about it. Do I do the envelope first? Do I do the case first? But I thought, as the case seemed to be available, although it was a bit cryptic on the Erica Synths website, because it kept giving longer and longer dates for shipping, but I'm going to have to make the assumption that's because they kept selling out of them and moving them on, and then more will be coming in later. But anyway, Thonk had some cases, right? So I took that to be the marker that I should do the case, because once we have the case sorted, then we can put all the lovely modules in it, and that's just brilliant. It makes sense. I mean, it always made sense to do something like the oscillator first, just to get something that gave us sound before we committed to something like the case. So yeah, I was into all of that. But now at this point, with more modules coming, let's get the case and power supply built. So if you're new to this, welcome. I do have a number of other live streams covering the VCO and the VCA. The build of them and the learning and the education and learning about the circuits, building it on breadboards, it all takes too long for a single live stream. So they are split into, I think it was 2 for the VCA, probably about 7 for the VCO, because there was all sorts of stuff going on. But there's probably 1 or 2 main ones. Main one dealing with the breadboard, and then the next one dealing with the soldering of the thing itself. Now, with the case and power supply, this is only like 10 pages long, so this is going to be just quick. We'll be home for tea at this rate, so with a bit of luck this is going to be easy, although I predict a particular problem we may have, but we'll see. I've glanced through the documentation, I haven't done anything more than that, so we're going to go through it together. So the plan for the evening is I will literally read through the instructions and talk about them and share them with you, and see if we can find out or dig down into what they're talking about, what they mean, and how we can learn about things from it, because the manuals for all of this Erica Synths stuff are excellent. They're put together by Moritz Klein, who's been doing a lot and does some fabulous work on YouTube with circuit design and getting the hang of what circuits and Eurorack and synthesis and synthesizers are all about. Fabulous work, and I've really enjoyed going through these in the last live streams for the VCO and VCA, and I'm looking forward to finding out more about power. So hopefully there'll be some things we can grapple with, and then there'll be a bit of soldering, and then we'll try not to set ourselves on fire. That's probably it. Michael, thanks that you liked my video on the Hydrosynth. Yes, that was a bit of an epic, and turned into a bit of a stress thing afterwards, because Ash and Sound Machines were not very pleased with what I was saying about their battery life. So I kind of had to put in some caveats, as well as doing it again with better batteries, because there was a danger that people would think that it couldn't handle being run by batteries, which it clearly can. It just can't handle it with the wrong batteries. Anyway, right, let's see if I can get myself a little bit sorted out. I don't know what bits we're going to need for what at this point. Get rid of my phone, no one's calling me. Good, let me just check for my camera skills. What have we got? Let's go for, is it that one? Right, so that's the overhead, that's here. I was a little bit rushed this evening, I'm afraid. Let's rewind a little bit on my document here. Can everybody see everything? Excuse me. Oh, crikey. Right. What a day. Don't mention the batteries. Right. So this, yeah, that looks pretty good. I'm in some sort of strange mode on this camera. I wonder if I can get it out of it. Hang on. Shooting mode. Oh no, that's always a disaster. Oh, dealing with the cameras upside down. Set up, just something that simple. Oh, there must be a button I can press. Well, that's helpful. I don't want anything to do with that. Thank you mode. There we go. No, maybe not. Okay. Is that better? Just look really, really washed out. Come on, hold it together. Why is that looking slightly weird? I think we're just going to have to go with it. I don't have time for anything else. Right. So, what do we get? We get this fella. I don't currently have a preview of what I'm looking at, so that's, but never mind. Well, I'm going to go with, I'm assuming that it's all working, it's all fine. You just tell me if something's terrible, yeah? Right, okay, so there is the metal tin that's going to form the basis and the base of our case. I've just had a terrible thought. No, it'll be fine. It'll be fine. So this is, so this is the tin case. We've got pre-drilled holes here, as you can see. These are set up for the modules themselves. It's not, you haven't got threaded nuts or sliding nuts or any kind of rail on here. This is purely a bent piece of metal in which they've tapped a bunch of screw threaded holes ready to accept the particular modules from this particular educational system. That's the plan. So this is not a general purpose case. This is designed expressly for it. It's cheap and cheerful and folded together and is going to do the job nicely. You can, of course, drill more holes in this if you like. Does that look straight? Yeah, relatively. But we're just going to keep it simple. Now, in this box, we have all of the different parts. This doesn't look like too big a job. There's a few connectors to solder, a couple of resistors, bits and pieces. Does not look too strenuous. So with a bit of luck, we'll be able to do the whole thing tonight. That's what I'm hoping. That's what I'm thinking. So let's just get these out of here. That's the board, PSU. Okay. Yeah, not a lot to it. So let's get stuck in, get rid of that box, and have a look at what we're seeing on here. That's what you're seeing. Yeah, that's right. That's what we want to see. Maybe we'll just have a close-up on the manual, which I think is that one. So let's start at the beginning. So this takes us on a journey to build a complete self-contained Eurorack system. Those who are already into Eurorack will find this a nice addition to their existing system. But you need a reliable power supply unit and a Eurorack compatible enclosure. You find a lot of information about these. Can you? Some nice projects are consolidated on the modular blog and this one on instructables.com. That's interesting. because that's interesting, because let's go bring this back in, that because what? Well, because the power supply has been the hardest part of Eurorack, always. It was the biggest barrier to entry when I started. Could not work out what it was all about. And people still talk another language when they talk about power supplies. It becomes like this vital thing that you need to have deep knowledge about. And I found that very difficult. But fortunately, since I've started, the whole case and power supply thing has got much easier. But there are still huge amounts of people out there, modular synthesizer people, who are still very tied up in the whole idea of power supplies, and will talk at length about, you know, voltages and currents and the importance of balancing those sorts of things out and getting it all right. And it's well meant, it really is, because there was a time when it was absolutely vital that you had to have a degree in engineering to cope with any of it. But these days you don't. You should be able to buy a power supply in a case and it will just work, and you will never run into that, oh, I've run out of power type problem. If you're building an enormous system with a tiny power supply, then yes, of course. But if you're buying a case and an appropriate power supply supplied to you at the same time, for instance, you're never really going to run into any trouble, I would suggest. So it's not something that we should really worry about too deeply. But good information on it has always been hard to come by. And like I say, it's the sort of thing you have to dig into to find anything out at all. 1 second. Oops. So, where was I? Yeah, so back to the whole power supply thing. There's a lot of interesting things you can read about in here, I'm sure. But let's go back to here. There's a nice circuit diagram, and Moritz is talking about how he got into DIY electronics in the 80s. Wow! Lots of stuff. High voltage is extremely dangerous and can be lethal. It's very important to know that. So we do not recommend building PSUs that connect directly to the mains. No, because see, that would be silly. Because essentially what we are doing here, put my hands on one, is we are going to build something. We're going to build something which is dealing with, what screen am I on now? We're going to be building something that deals with this sort of thing. This sort of power supply, ultimately. A laptop power supply. Now, the advantage of using a laptop power supply is that all of the dangerous stuff is done inside this little box here that we don't have to have anything to do with. So we've got 240 volts coming in here, from here, but only about 12 volts, or 9 volts, 10 volts, something like that, coming out the other side. And that's vital. So we don't have to deal with mains voltage in here and risk blowing ourselves up. No, we're only dealing with sort of laptop level. I mean, you could probably stick a laptop power supply in your mouth and it won't kill you. It will tingle a bit, that's for sure. But you're much less trouble. Don't do that at home. You're much less trouble dealing with this sort of power. So that's the power supply that we're going to build. Is something which is going to be run by a laptop power supply, which is low voltage relatively, and is not going to kill us. Okay, that's quite important. That the power supply that comes with it, I think, because I might have got this modelled up, I think is this one. Did you get one similar to this? See, I haven't taken that off, which means it must be new, which means it must be the one, I think. Are you ready? Oh, that's immensely satisfying. Immensely satisfying. So I think that's the one. So all of the dangerous stuff is taking place inside here where we don't have to worry about it. At this end, it's simple, easy, 12 volt type output. Yeah? Cool. Back to the manual. So, with all that considered, we decided to design a power supply based on a DC/DC converter. It takes 12 volt DC from a wall wart AC/DC adapter into standard bipolar plus and minus 12 volts. Increases the voltage in the Eurorack system. This ensures the voltage in the Eurorack system never exceeds 12 volts, which is great. That's what we want. Awesome. So each Eurorack module comes with technical specifications and its power consumption. See, this is this business dealing with how much power you're using in your system. And while it is something to know about, my suggestion is purely that if you get a case and an appropriate power supply, it's not something you really have to worry about. If you're DIYing an entire wall of Eurorack, then yeah, sure, absolutely. But you know, you shouldn't have to go into it that deeply if you're just building a few rows of Eurorack. Okay, so let's go on down. So it tells us here what our case and PSU DIY kit should contain. So let's just have a look at that. So one row, 84 HP case, yes. A wall wart adapter with 12 volt DC output. Can't see because the plug covers up all the writing, but we're going to make the assumption that that's right. Good. DC socket and power switch. DC socket and power switch, that's in this bag, I believe. PSU PCB, which is this. That's good. DC to DC converter. That just sounds wrong, a DC to DC converter, but I guess that's what it is. I think that's this. We will discover these things. 14 sockets and components. Yeah, that all looks about right. Right, so we're moving to the schematic. Well, that's frightening. So presumably these are all the sockets, all the sockets that we're looking at. We're looking at it sideways. I don't really care just at the moment. Oh, I'm starting to care. Can I turn this round? Yeah. So it says only one power converter modules are installed, right? Power in. You've got an additional board, something or other, optional power in. Okay. You've got a couple of resistors with diodes, optional 5 volt power supply. Right. And then it shows us here on our sockets that you've got gate and CV going through the power supply. I think that's talking about some kind of CV bus. That's interesting. Then you've got +5 there, +12, load of ground, and -12 across all of them. Interesting. So apparently XS1 is a socket for the input. Right. Oh yeah, come down here, XS1, X2. And XS2 is an optional socket in case you want to connect several boards in parallel. All right then. VR1 is a resettable fuse in case there's an accidental short circuit. Great. VD1 is a Schottky diode, or Schematic, that secures reverse polarity power supply protection. In this case, it works in junction with the resettable fuse. Diodes pass current only in one direction because the cathode on the VD1 is connected to +12 and the anode to ground. It will not pass current through, and normally it will have no effect whatsoever on the circuit. If a negative voltage, however, is accidentally applied, then the diode starts to conduct the current and essentially makes a short circuit. Great. The capacitors C1 to C3 serve as energy reservoirs to keep the power supply voltages stable. There's a couple of LEDs, our voltage OK indicators, connected in series with the current limiting resistors R1 and R2 respectively. They're designed to operate in a certain current range. The more current flows through the LED, the brighter it shines. There's a certain maximum current the LED can handle, so limiting resistors are required. The anode of the VD2 is connected to the +12 through R1 and the cathode to ground. If there is a +12 on the rail, current flow through R1 and VD1. Remember, the diodes pass current in one direction only, and the VD2 will light up. Same goes for VD3. If something goes wrong and there's no 12-volt rail, the LED will be off or half dimmed. Good to know. Then you've got your power supply connectors and a small schematic around DA1 for an optional 5-volt power supply. Parts are not included in this kit. Built around a DC linear voltage regulator, often referred to as a low dropout regulator. Some Eurorack modules require an external plus 5-volt supply. And as you saw from the connector pin out above, there's a dedicated pins for plus 5 volts. These educational modules do not require a plus 5-volt supply, therefore that part is optional. So that's also useful to know if you're thinking about adding other modules to this case, or using this case for other modules. Interesting. So it says the PSU assembly is straightforward. Just solder all the components, off you go. Mind the orientation. A notch on the silkscreen must match the negative lead on the capacitor. LEDs and PSU sockets, once completed, it should look like this. Oh. Oh, I like that. Right, and then it's done. Well, I mean, that's exciting. So on this occasion, we don't seem to be breadboarding anything. We a second. Oh yeah, I don't know. So right, yes, okay, so it's just me then back here at the second. So it looks like there's no real no build guide or step-by-step anything for the soldering of this. They just want you to do it. So that's going to be exciting. So that, I guess, is what we're going to do. Let's put this bit away for the minute and prepare ourselves for what's to come. So this is the point where I get very anxious, because it's expecting me to get on with it, and that's scary or shocking almost. So I think what we should do is so we don't need to worry about the power socket and switch, because that goes into the case itself. Put that to one side. So we are talking about all of these bits and pieces, yeah? So I think we're going to need to do all of that. Let's get all that together. Are you still with me out there in Wonderland? Biggest problem with the case and power supply is that they are needlessly expensive, in your opinion. Yeah, well, I mean, I've had this conversation many times. I don't think they're needlessly expensive. They just are expensive. I mean, if you buy a set of rails, which I don't have one to hand, they cost about 40 quid because they're precision made rails. It's not some piece of old crap that's just got some holes in it. It's something which is precision made, and an aluminium extrusion, that sort of thing, with threaded nuts or other nuts, and it just costs money. So just the rails themselves are going to cost you 40 quid, say, and that's without including any other materials like the case. And how much would you expect to pay for a power supply? I mean, just the laptop adapter is often 15-20 quid. So then you've got to think about the electronics inside which run all of that and do all the monitoring, and LED and the PCB. So, are they expensive? I mean, they have a high value, but I don't think they're needlessly expensive. But there's no reason why you can't build a Eurorack case out of a cardboard box. I've done that. I did a video on it. Or there's no reason why you can't get a much simpler power supply like this one. Put this under here. This is USB driven. I haven't tried it out yet, but it's just a small Eurorack power supply plugged in via USB. This cost 30 quid, 40 quid, can't quite remember. It's only the other day. But, that might be the way forward, and we're building something very similar, I think. But I hope to plug this into some kind of 1U thing I'm doing. But that's for another day, not today. Anyway, sorry, there's a couple of questions I just wanted to get to. Hello in Teddington, how you doing? It's good to see everybody here. Oh, Ken, you're talking about sort of CV bus. Yeah, could well be. They didn't mention that, did they? Is that something that I skipped over? Because I did skip a little bit. Impedance capacitor. I don't think so. We might come across it later. But yeah, it's sort of a CV bus connection through the power supply is a common Doepfer invented protocol or technology or something, and I've never come across it or used it myself in any way, but it is a thing that you can do and is usable and all those sorts of things. So maybe that's what's happening with you, Ken. Oh look, somebody else talked about the modular. Yeah, okay, cool. So without having to patch them. Okay. Would I recommend the Moog 104 HP as my first case? Yeah, it's great, but you will need a power supply for it. You have to buy that extra. I started off with the 104 HP cases. I thought they were brilliant, and I have 6 of them. Well, no, I have 4, and I have 2 Behringer ones for my sins. But I have them all over there, all racked up. They look great. It was great. I liked the way that you could have that case with a power supply, then you could buy another one, and you could expand that way without having different things, and you could connect them up. That was that modular sense of building a larger system. I really appealed to me, and appealed so much that I didn't mind the price, if you know what I mean, because you are rebuying things as opposed to buying a larger case, which is probably better value for money. Anyway. A niche tax. No, it's not a niche tax. It's a let's try to make a living out of building something with our hands. It's not a tax. Don't like that at all. But so yeah, no. I mean, Eurorack is a craft fair. You know, you'll go into a craft fair where people have built things with their hands and trying to make a living out of it. So it's not mass production. It is in a small number of cases, but mostly it's small industry. And so in order for any of that to exist, it has to have a value. You know, it has to have a value. So don't see it as a tax. See it as what it is required to be paid in order to have any of this exist at all. Anyway. So... but also, Mike, you say you're scared and disappointed by lack of step-by-step. Yeah. Well, I've got plenty of videos on soldering irons. Oh, not on soldering irons. On soldering. And, you know, don't start with this. Start with one of the other ones, which should give you a better step-by-step instructions on what is going on. That would be better. And also, watch my videos. That would be great too. So, right, anyway, so that I can't really put it off any longer, so let's get these bits out. Better turn on my soldering iron over there. Worry about the air in a minute. That's just a piece of plastic, the sort of thing you usually find chips attached to. Maybe it was attached to that. Maybe. Anyway, so big fat thing, got that. When we lay it out like it is on the screen. So like that. These strange nutty things. Like that. Some kind of capacitor. I've got 3 capacitors. 1, 2, 3. A whole bunch of these. Put those to one side. So together, we're going to not be scared, and we are going to be awesome at this. LEDs, diode. I've only got the one diode. Should I have more than one? I don't know. Right, so it's straightforward. Just solder all of the components on the PCB according to the silk screen. Right, let's have a look at this silk screen then. Okay, well, if nothing else, I can put these on, I think. I'll do those in a minute. That's the optional 5-volt section. Don't need to worry about that. Alright, nothing else there. Here. Going to need to have my magnifiers because my eyes are shot. Right, so a 3K resistor at the top. I've got, what have I got? I've got 2 resistors and a 3K down there. That appears to be it. That's all. So that's those 2. So that's relatively simple. VD2. And VD3. I think that refers to the LEDs. I've got a green and a red one. Green goes at the top, red goes down the bottom. Okay, now it doesn't tell me which way round they go. Rats. Okay, capacitors, C2, C3. Alright, so there's 2 I think that are the same. There's no value on the board for the capacitors. These are 220 microfarad. And this one is 100 microfarad. This one does have 100 microfarad written on it, so that must be that one. Oh, they do have it written on, just sideways. Okay, good. Good, good. So far, so good, we think, other than the LEDs are the only trouble at the moment. Then over here, we've got these, which allow us to connect on. Yeah, okay, no problem. This big fat thing, obviously, which goes in the middle here. Now we do have a photo, so we know which way up it goes. And in fact, it can only go one way round because look at where these legs are. You see that? So you can't get that wrong. So you can't get that wrong. Well, you can go forward and backwards. That's a bit interesting. So is it there or is it there? Dun, dun, dun. I think the picture says it's there. So good. And then we've got this big flappy thing. Doesn't look like it's got an orientation. That'll go in there. And here is a single diode. Good. Good. So my way of doing things is to do it in height order. Shortest components first. Thanks. Well done, Job. Small holes. What? So that's what we're going to do. It is relatively simple. We only have the components that we need. So let's put in the resistors and the diode and solder those in and see where we get to. Let me try not to do anything nasty on that. So it's going to bend these into shape. do nearly what's this called? Diode at the same time. Can't get it wrong. So with this fella, this has to go. See the line on that? That line needs to match the line on the diode. This fella here goes through, nice thick legs. Pull that through. So that's our starting point. Now I could just, you know, just to be a little bit anal, put that in that way up so that's the same way round as the other one. Prettier that way. Prettier, yeah. Okay, good. Let's just clear those bits out of the way. I'll put my fan on a little bit to blow a little bit of air. Hopefully that's not picking up on the mic. Good. I'll put my safety specs on. Bit of solder. And see all that all right? Let's bring this in. There we go. Then all we do is heat up the pad and the leg if you can at the same time. Stick some solder in. Let go. Heat up the pad. Stick some solder in. Take the solder off. Take the iron off. Simple. Easy peasy. I mean, that's the one thing about this board, it's very, very open, and we're going to be doing an awful lot of soldering in a minute. In fact, in some ways we could just solder 2 of these on, because that's all we're going to need for the system as it is at the moment. But it will mean I'd have to take the whole thing out again to resolder all the rest. No, you're just going to have to put up with me soldering for a little while. Okay, anyway, over here. Over here. Heat up the leg. Because it's a thick leg, it might take slightly longer to heat, or you might find all your solder just goes straight on the iron. Cool. That's done. Get my clippers. Good. So far so good. So what's going to be the next tallest? I think the LEDs. Now this poses a problem. So here's a question for you. There's no marking on here as to what's positive and what's negative. What we do have is a square hole and a round hole. Now these have been inconsistent, I've found in the past, as to which is positive and which is negative. However, with the kits we've done so far, they have always been consistent, but I can't remember which way round it is. Looking at the capacitor here, it's saying that the notch is for the negative. So this notch here is for negative, which means the circle is negative, in which case the square is positive. Are you with me so far? So that's my thinking. What does everybody else think? The temperature is 350 on the iron at the moment. So I'm just going to stroke my beard for a bit and wait for anybody else to offer an opinion on which way round that should be. Now I could have a look back up at the this thing here. Is that going to help us in the slightest? So these are the LEDs, and it suggests for the positive, I mean, you know, if we assume that those are connected, they are connected there, and so this one, positive plus 12, is connected to the square. I don't know, because I don't know from a schematic is the what's positive, because it's not really positive and negative, is it? It's the one with the line or not the line. I don't know. Peep at the photo. What's the worst that can happen? Well, it won't work, you fool. The light won't come on. I want the light to come on. Looking at the photo is not going to help because, oh well, no, it might, because you do get a flat edge, don't you, on the LED? Just like mildly. Damn it. So on the plus 12, it goes into the back of it, which made me think it would be negative that way round. Whereas for the minus 12 volts, it's going into the circle. No, the circle is negative. Oh, you see, I don't know. Yeah, I think I have to have a look at the photo again. Let's go into that. Photo's not that high res. That's as close as I can get. That's not telling me anything. See, I know via the capacitors the circles are negative. So can you tell me out there, is the circle, flat edge is negative, yeah. Minus 12 and power looks to be part of the square circuit. What? Yeah, maybe. I mean, does anybody know if I try? Yeah, the schematic. Look, okay. So here's my problem. I know I'm a problem. I'm always a problem. Is that I don't know when I'm dealing with LEDs. Normally, when you're putting in LEDs, you're putting, you know, it's labelled positive or negative on your PCB, and so long leg positive. Long leg is always positive. We know that long leg is positive. Long leg goes next to the one that says positive. Now I don't have that. I have a square and I have a circle. Now on the schematic, can you see that there? There's no positive and negative either. I've just got, you know, can't go in and can go in. If you see what I mean. So on an LED, is the flat bit a positive side or is it the negative side? Because I don't know that either, because I've never thought about it. Do you see what I'm saying? Because I know which of these is positive and negative, which of these, because, you know, the long leg is positive, the short leg is negative, that's the flat side, that's fine. I just don't know which way round it goes on here, because I don't know which way stuff flows through an LED. If the LED has a flat edge, that corresponds with the line on the diode. Okay, that makes sense. That makes sense. Maybe we're going to have to Google it. Would you mind Googling it while I'm fiddling about here? So then if the negative is the one with the flat line, that would go that way round, so that the long leg is in the square, and that's negative, and that would match what's on the schematic, because the top of this resistor goes into this square one. You can see on the underside. Yeah, so those two are connected. So according to the schematic, this resistor needs to go into the back end of the LED. Yeah. Are you with me so far? So the resistor here, like on the schematic, bottom end of the resistor goes into the LED and should go into the back end, so that the line is the other side. Whoop. In which case the square is positive, and that matches up with the capacitors, which is also positive, negative, positive on the square. Yeah? This is the plus 12 we're talking about here, yes. So it follows that this resistor goes into here, has to go into the back of the LED. The back of the LED is the bit without the line, which is, in my world, positive. So that has to go in that way up. Now, this end, well, I'm assuming that this resistor goes into the negative, which is the line, which is what the schematic says. The resistor on the negative 12 goes into the line, and if the line is the bit that's negative, which is the flat bit, which is the shorter leg, it should go in like that. So on negative 12 volts here, I've got the flat bit pointing to the resistor, and the non-flat bit going somewhere else, don't really know where. For the 12 volt plus 12 volt, I've got the flat bit facing away from the resistor, and the resistor going into the non-flat bit, or the positive leg as I would see it. Yeah? So I think we have deduced this to be right. I think it would be really nice if that information was in the manual, or it was a bit clearer on the PCB as to which leg, because it tells you to do it, but it doesn't tell you which it is. I mean, maybe we're supposed to know this by now. Maybe we are, but you know, I think the lack of instructions on this are a little bit worrying, as has already been said, because you just need that little bit of confirmation that you're doing the right thing. Okay, I think we got there. I really do think we got there. So I'm going to solder these in. I might even cut the legs off. Which is a sign that I don't want to have to take them out again. Yeah? Cool, right, let's go with that. Let's just go with it. Go with it. Go with it. Go with it. I mean, it's all learning, isn't it? I mean, that's the point, isn't it? Really, that we've had to work it out through logic and deduction, and maybe that's all part of the learning process. Maybe that's not heating up, is it? Come on. Thank you. Maybe I'll leave. Maybe I won't cut the LEDs. Yeah, we were talking about how it matches with the capacitors, yes. But that just throws up red flags for me, because I have had PCBs where the square is different depending on the component. You know, I've seen it to be so inconsistent, then yeah, that I don't trust it. I don't trust it as a rule of thumb. So yeah, I'm going to leave these legs a little bit longer, just so it'll give me something if I do have to desolder them. But I'll make them small enough so they're not in the way. Does that sound like a wise and old man decision? I think so. Move the PCB camera left. Who's left? To what? To which? Which bit are you not seeing? I mean, I've got to keep it this way a little bit. Okay, because yeah, no, all right. I'll try to keep it in frame. Anyway, I was zoomed in a bit, so I can zoom out and we can see a little bit more what's going on. Okay, good. Right, so those are in. But as you say, if it, you know, it's not a system critical component, it just means they're not going to light up. And we want things to light up because that's nice. So what do we think we should do next, height-wise? Probably these blue things, and maybe this capacitor. Maybe I can do all the capacitors at this point, because they're, you know... Oh, I need to do this, that thing. So the lines on this don't tell us a huge amount. Move the PDF to the upper left. What are you talking about now? What? Move the shed left. Yes, thank you. Yeah, so we've got more holes on here than we need, but from the photograph we know, and this square on here, that it must go that way around. It can't go the wrong way around because of the holes in the pins, so it has to go this way around, like that. I think we should oh look, those are slightly smaller. Oh, sod it. These things here, these blue bits, need to go in, I think, so the wire is pointing out. Yeah, they're for wire connections. And for this capacitor, long leg positive going into the square, negative going into where that line is. I'm going to need something to hold these on when I turn it over. Have to have a handy bit of plastic right here. That didn't work, did it? Cool, try harder. Put that in. Maybe I can bend it a little bit. No, there's not really a whole lot you can bend with that. I just need to keep that. No, that's not going to work. Alrighty then. Come on, think about it. Take that out. Put that in. Try it like that. Okay. Right, not great, not great. Let's, if I let, oh yeah. No, you just have to do it in high order. There's no getting around it really. And these are so big and chunky, you can get them in like this. That's fun. No, you can't. I'm trying. Go on with you. Go on. Yeah, okay. So I stick something else under here. Hold it up. It doesn't fall down. Stick another one in over there, look. Okay, that'll do. That'll do. This is not critical, I don't think. Hi, Skull. How's it going? You join us at a delicate moment when everything could go wrong. Alright. That's a bit wobbly. It'll just have to do. So with this bit, what's the problem with doing it one at a time? If I do one at a time, it will just tip over. I want to keep it balanced. So if I do one of these, it's, I'm going to have to stop it tipping over somehow. So if I can use the other one as part of that balancing situation, then I can get both of them in, and that's even better, I think. So I'm going to apply a little bit of pressure with my finger. It doesn't really matter if these are particularly straight, so I'm going to heat that up. Give it a little bit of solder with my super ambidextrousness. Come on. Come on, I'm tickling it. Come on, come on. Heat up. Okay. That's good. I'm going to hold it just till it cools. Then I'll do one leg over here. Exactly the same way. At the moment it's just going onto the iron. I need it to go onto the pad. That's better, so that's now nicely fixed. I can do the other one without having to hold on to it quite so hard. That one. Good. Those two are in. That's not... Look how straight that one is. Awesome. Awesome. Right, let's do this big fat thing. Goes in like that. I think I can probably turn it over all by myself. Good. See how it tips away a little bit because this is the wrong height. That's pretty good. Terminals have a lot of metal attached, so a soldering iron needs good thermal mass to not let the joint suck out the heat. Oh, okay. Ooh. So again, these have got lots of metal. So it may take a little bit of time to heat up. Trying to just keep it flat as best I can. Tickle the end of the iron with the solder, see if I can persuade it to start flowing. Ooh, now it's stuck. I'm going to add plenty of it. That's beautiful, that is. Beautiful. Soldering irons are funny things. Sometimes they just, you have to somehow get them just right sometimes in order to, see, like I've bent my solder trying to get that to work. Come on. Something's not right. Bend it in the right way. Well, I am not getting that through. Let me clean the end of my iron. Okay, that's a bit better. Well, I'm doing an awful job on this particular one. Ooh. What are you doing? The screen's moving by itself. Weird. Okay. Come on, just about. Ooh. So, need to get plenty of heat into there. Oh, that's already better. Yep. I did used to run my iron hotter, yes, but then when I did the dysphonia, the dread box thing, it said in there, don't ever run it hotter than 350. So I put it down to 350, and actually it makes a difference. I'm noticing a difference, so I am tempted just to bump it up a little bit more. See, that was beautiful. See, it's just patience and getting it sat in the right place. That's all that it's about. Just gotta give it a minute. Well, I say that, but you just got to get it in the right spot. Because it's fascinating telly, this is. Come on. Come on. It's interesting, it was the middle one on the other one that was the most trouble as well. I wonder if that means anything. Oh, I'm just making a hash of it now. I don't believe that's really heated up at all. Let's try it from a slightly different angle. Okay, got some flux moving, Alright, I think that's okay. Yeah, that one's better again. Odd. Let's hope I did that right. Great. Super, I think. Now, I don't know what's going on here. I think it might be that attaching itself. So, now we need to do... No, we're nearly there. Nearly there on the components. This is the capacitor. And this goes long leg into the square. Negative down that way round. Like so. No messing about. I have lost the ability to heat things up. Oop. Then let's put these other two in. Long leg positive into the square, negative into the circle. Long leg positive to the square. That way around. Good, and then this weird one. Put that one in at the same time. Oh, sorry, can't see. There. Goes in like that. that. Funny how different it is as soon as you get into thicker components, thicker legs, more metal, as Ian said. It does make a difference to how well and easy these things heat up and how the solder flows. It's very interesting. When you're used to doing weenie things. It's all just going on my iron. What is up with me tonight? Okay, that's better. There we go. And I've got all of those pads to put on. All those sockets. Oh no! I've bridged it. I've bridged it like a good one. Oh, what a disaster! Right, I better have a bit of a solder sucker type experience going on. If you can see that, I've just completely joined those two together with an excess of solder. Oh yeah, it's very dramatic. That's better. Need a little bit more solder on, which one was it? This one. So I've taken a whole load of it off. Just a dab. Yep. Good. Let's take these legs off. So how are we doing for time? Okay, Struth. 10 to 9, that means I've been doing this an hour and a half. I did start a bit late. Come on, we can do this. We can do this. So that is, bar all of these fellas, that's the soldering. So I suppose I better get on with all of those fellas. Now, this is, I wasn't thinking enough because look, I'm going to have this problem with this is all too high. I should have put these in before, but for some reason in my head I wanted to leave it till later. Oh, I'm an idiot. I'm a complete idiot. Let's not worry, because there is something I can do. Now, this the board doesn't really tell us where the notch is particularly. So yeah, so we're going to get to that next step in a moment. So all I can go on really is by the picture. Now there is this little slide bit here on each of these, which I guess would indicate, and also that bit square, so that's probably pin 1. No, I don't actually know. I don't even know if that's important. But what that seems to indicate, but again it really could say, and it doesn't say, is that refers to the hole on here, because in the picture they're all round this way, so that must be what it must be. Yeah, get a chunky chisel tip. All right, So I'm going to put them in that way around. Now you can usually, maybe not on these, maybe they're too thick, you can bend them so they stay in a little bit, because otherwise I'm going to have a little bit of trouble getting these to stay in. But let's see what I can do. Think about it, think about it. Maybe I can bend it a little bit like that, one end and the other. Does that make it stay in? It does not. Let's try that again. I mean, don't make me get tape out. Because I can't. Oh, I'm such an idiot. I'm usually really good on the whole height thing, and I was talking about the height thing, and then I completely failed to do the height thing. That's not going to stay, is it? Right, alright, tacky bits of tape then it is. So if you're looking at this, do those, after you've done the LEDs, right, do all of these do these after the LEDs. That's the answer. I guess, should I try to do them all at once? I could try at least tack them in, couldn't I? It's a lot of tape. Well, look, let's do 4. Plug in a power cable to increase the height. See, that's not a bad idea. I just don't think I'll be able to get them very flat. So what I'm going to do is I'm going to try this, and then maybe put them onto a bit of push against a piece of something or other, because that's also helpful. Something like that, you see, so that it pushes up against it. See, that's pretty good, and it's balanced. Right, okay, we're on this over here on the camera. Are you with me? So, oh, are there triangles? Somebody's saying there's a triangle on here. There's a mark on here that matches with it. Nah, I know. Anyway, I've just said it smells like I've just melted something. It's always a good sign. So let's just tag a corner. Come on. I think I'm going to have to turn my soldering iron up because this is just all taking too long. So that's in. Let's make sure that's flat. That should be good. That's good. Yeah. Yeah, looking good. I'm going to do an opposite. Now I'm going to check it because I just want to see that those are relative. Don't lose that. Relatively straight before I solder the rest of it in. And they are. So I'm going to keep on going. Tag as many in as I can, and then solder the whole lot in one session, if you see what I mean. I've forgotten how to turn it up. thought I just pressed the up button. Oh, here we go. That one. Let's go up to 380, I think. Thinking about it. It's going down again. Why are you going down? Whatever it was, that wasn't right. So, up. Hold it. That's better. Okay. So now, of course, you could have a really nice tool which holds things properly on both sides and grips things and allows you to solder everything beautifully straight. That's awesome if you have such a thing. I do not. I tend to manage all right. Those are fine. Those are completely fine. Had some ice cream in a car door. Find all sorts of terrible things in our car door. I'd never advise eating any of them. Okay, where did we get to? About here? Yeah, okay. Oh, there it goes again. It must be the heat from the soldering iron. I think that's probably it that's moving the page. Yeah, the increased temperature is definitely helping. Right, Those are all in, relatively straight. Now I can just solder the whole lot all the way across. Alright, so it's 9 o'clock. What's the estimate on getting this done? 5 minutes? 10 minutes? Right, let's get into action stations, and just solder like a good one. Let's go. See, good start. Come on. See, that's not heating up. That's better. You can sort of tell when it's really just not going onto the pad. You sort of end up with it looking too much like a ball as opposed to a volcano. It's always worth going back over that again. You want that solder to go in and stick nicely to that pad. That's one. Two. Three. Four. It's alright for you lot drinking beer. I'd never get any of this done if I started down that road. I got one saved for later. See, this particular, in fact these couple here, these are not sticking out very well. I think I might have stuffed those ones up, but provided that there's some kind of grip, then they should work well enough. It's just they're going to be a little bit proud on the other side, and so not completely flush. Oh dear. I suppose if I had time I would solder sucker them out and redo them, but I don't think we do, so I don't think it's completely necessary. It's just not going to be as tidy or even as it could have been, but it should still function. The rest are better. What happened there? Obviously had a bit of a moment. No, these are all like it. Oh, maybe I just did a really rubbish job. No, maybe I did. Oh well. Too late now. Had I had soldered these earlier, well, I could have done them all brilliantly flat, then I wouldn't have had this problem. Got too preoccupied with the LEDs, that's what the problem was. So not only were they confusing to put in, but they've cost me a load of time in putting these in. Oh, losing my eyes, losing my focus. Oh, what are we doing? Oh, nearly there! Did anybody see the Swiddy announcement today? Does anybody think it might be an early April Fool? It was almost as funny as my Molten 2500 modules skit. Two more. Yeah, in fact, the interesting thing about the Swiddy is that it's Bluetooth, as you say, and wireless charging, making it completely wireless. So you don't even have to have any kind of cable hanging off it. But it has no other connections. No CV, no regular MIDI, no sync in and out or anything like that. So you can only control Bluetooth devices. And I wonder how many of those you've got. I don't have any. No, I think I've got... Oh no, I think the other Bluetooth MIDI device I've got is a Bluetooth MIDI controller. The Rolly Seaboard. I think that's it. So it's of no use to me. But then of course you could buy some CME Bluetooth adapters to make all your stuff MIDI Bluetoothy. So it's a bit of a ruse, really. I think they're going to find people buying it and not realizing that they can't plug it in via normal MIDI. Ah, it's there. It's there. It's done. Let me have a look at that, make sure I've not shorted anything. That one's a little bit close. There you go. That one's a little bit crap. A little bit more solder. Still a little bit too round for my liking. Come on. Yeah, okay, better. Good. Anything else? Those LEDs still sticking out a little bit. Alright, so let's take the paper off and see what a pig's ear mess I made of it. Well, they're all sticking up a little bit, but you know, ow, it's fine. They're good enough. Good enough. Good enough. I think I've got a bit gritty. Thanks, Ken. Oh, the Wavefront Eurorack module. Yeah, I do have that, funnily enough. Yeah, I do have that. I keep meaning to do something far more interesting with it. I mean, the fact that it is Bluetooth by itself means I could do interesting things with it. And I just have never gotten around to it. I mean to do so. I mean to use a meter to check the continuity on the bus board. Make sure there's no shirts before you plug it in. Yeah, shirts can be horrible. May not be self-resetting. It is self-resetting, apparently. But what do you mean exactly? Do you mean... I don't want to spend too long on this because time's getting away. But do you mean if I put this on the beep thing, where it goes? That's not the beep thing, isn't it? I don't know there's the beep thing. What have I done? It is that one. Okay. Just about. So are you saying, what are you saying? I can't see. So if I press on that one, is that a good thing? Check from top and then the next row, no beep equals good. But I've got a beep all the way across the top. Test the pin on the far left, the notch facing you. See that the meter doesn't beep when you connect to the next pin to the right. So you want it this way up, far left. Okay. What next one down? Yeah, no, I think that's good enough. All right, thanks for that. I appreciate the care and all of that, but we need to move on. So, blah 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 blah. Did that. Check your soldering. Yeah, that's all super. Now put it in a bath of acid. Yeah, okay. So now we're getting on to the tricky bit. And what time is it? 9:20. All right, I want to stop by 10. I think that'll be long enough, don't you? So we're now looking at doing the switch part. Now this is where I thought we might get into trouble, for the simple reason that there's no wire included. So it's asking you to add wire, but it doesn't tell you what this wire is or anything about it. Let me just skip ahead to see if there is anything else about it. No, I think it just goes, ta-da, you did it. There's a soldering appendix. That's it. So there's no mention of this wire at all. What it should be, how big it should be, how thick it should be, and the fact that you should have it. You know, I didn't realise this until I had a quick look. I thought I'll just have a quick look in case there's something I need to find. And yeah, you need to find bits of wire. But this is wire, I mean, presumably, because I don't actually know, presumably it needs to be wire which is suitable for running DC power. This is what we've got. Switch, DC power. I mean, we're not talking about mains, obviously, so I don't need to strip a mains cable. But I will need something. And I was thinking, what was I thinking I might have? So I have this wire here. I bought this for the Cosmo modules I was doing, or going to do, will do in the future. But this is just sort of regular wire, component wire, not really power wire. And it says single core, 22mm. Doesn't say anything more than that. Equipment wire pack. So prepare a DC socket. For a better solder joint, use a file. What? To clean the chromium plating from the socket lugs. Oh. And increase your temperature at solder joint to 400 degrees. Well, I don't have a file. I'm not going to worry about that. Something that's the same as the wires in a laptop cable. So I might have another option. I'm just going to go and have a quick look. Bear with me. I've got this. This is wire for the Deckard's Dream power supply. I think I just can't see my eyes. Yeah, but that's all sorts of multi something or other. So that's no good. That's something else. That is. This is. This is wire. I don't know. Electronic wire and cable. Is that different to that other stuff? I mean, is this all I need to know? The cable you have there will be fine, says Tonal. Alright, well I'll go with that then. Scrape the lugs or something. What, these lovely lugs? I mean, they're beautiful. Why would I want to scrape them? with something. I don't know what I'm doing. Robin says that stuff will be fine. Alright. Giving that a bit of a... I don't know what I'm doing. So anyway, it says blue and purple. I mean, is that important? No, I'm only being silly. So let's just bring this out a second so I don't miss what's going on. Right, so, okay. So there's a bit of blue. So, I mean, I'm going to try and follow the picture just so it keeps everything together. Now, I don't have wire strippers. I'm sorry, I don't. So I just have to make that bit up. So, a bit of that. I need to get some. I used to have some. It's the sort of thing one used to have knocking around. Do you know what I mean? So there's some purple. Right, cool, right, cooking on gas. So, bit of this, bit of that. Oh, look, one's longer than the other. Does that matter? No, I don't expect so. So, magic stripping business. Like that. Is it single core? Yes, great stuff. Cut the blue wire. Oh. Right, bit of blue wire. Failed. You got your LEDs around the wrong way? Well, that's exactly what I'm going to do. I mean, I probably have. So, did you work out the positive negative? Evidently, you didn't work out the positive negative thing then. Because that had us going here as well, mate. So did you put yours in the same way around as we did, or don't you know what way we put it in? I say we because I don't want to take responsibility for this just myself. Oh, come on. You can do it. You can do it. Come on. Come on. Come on. Come on. Oh dear. Maybe I'm just not concentrating enough. Ow. Okay. You only just got here, Robert. Okay. Well, yeah, we had some trouble because it's not clear at all which way around the LEDs go, and we feel we deduced our way through it, rather, and we might have done. Oh look, there's a feet, I suppose. Those aren't they? Okay. Anyway, right, two wires. Two wires. There's a blue one. Blue one. There's a hole. Use a forget all that. Put this up to 80. I mean, what is it? How did I do it last time? Does anybody remember? No, that wasn't it. It was holding... That wasn't that. It was holding this. There we go. $400. Cool. Right, okay. So this goes in here. And what? Do I bend it over? I'm supposed to do. Right. Let's do it. You Googled it and still did it wrong. So Moritz, yeah, I mean, if you're watching, you know, you need, just tell us which way around those LEDs go. It'll save everyone a whole load of bother, unless you want to do a section on desoldering. Now I'm going to be chasing this thing around here, aren't I, like some idiot. How am I going to do this sensibly? Okay, I've got a little bit of purchase now. You beauty! That's good on there, that is. That's good. How am I going to do this next one? Maybe I need to think about this a little bit more carefully. Oh, now somebody gave me these things here. Ah! Now, this is the sort of thing that's going to help. No. It's not going to help at all. Right, let's try that. Try that. So how does this go in here? Just go in like that. Well, I need 3 hands, obviously. Oh, look. Quick, let's give it a go. How is this? It's never going to work. Almost. It just fell away at the last moment. Come on, come on, come on. You know, I mean, I could think about it and get it and do something more useful. Just want to get this. Can I melt this? Yeah. Okay. See, I'm not remotely practiced at this sort of soldering. Soldering on the PCBs, yeah, no problem. This kind of free form, free flowing, what the heck are you doing type thing? No, not so much. So anyway, look, it looks like the picture. Well, that's just bloody brilliant. Next, for safety, use pieces of heat shrink tube. Now again, there's no heat shrink tube in the pack. So, blue tacoplastin. Oh yeah, okay. But as it happens, I have some. I do have some, so that was lucky. Does that look about right? That looks enormous. Anything smaller? Now I bought this stuff as like 500 pieces for 225p kind of thing, so I can't vouch for its awesomeness. Let's try a bit of this. Oh, beautiful. Yeah, all right, have a bit of that. Oh, going away. So that goes over there nicely. What did I do with the other bit? Did it just go? I thought I put it down safely. Oh, there it is. Right. So heat shrink is cool because it just means that these things won't short or cut themselves. Now, is there anything to tell you how to use heat shrink? No? Okay, so my understanding of heat shrink is that you need to heat it up. So I tend to use, probably wrongly, a bit of the iron, and that shrinks it because of the heat, right? So that it sticks. This is probably a terrible idea, but this is my understanding of it, and I'm just going for it. It always smells a bit melty, which means I'm probably doing it wrong. But heck, that'll do. I'm going with that. I think that's safe. Right, now fix the socket into the case. Use pliers to tighten the hex nut. There's a hex nut. Oh, there's a hex nut. Also insert a power switch in the rectangular hole. Right, so let's get our thing back. Don't need those, were rubbish. They weren't of any use. Can you see this? So let's put this here. One sec. Like that. So this, I think, you see the hole in there? Like that. So that's going to go like that. Now I do have a washer as well. I assume the washer is going to go on first. Use pliers, it says, to tighten. So I'm going to put the washer on, and then that on. I do have the same colour. Yeah, absolutely. You know, it's the precision is what you're here for. How'd you get pliers in there? Oh, I've got pliers. It's like an Ealing comedy. It'll do, it'll do. It's fairly tight. Oh, but no, they've got in the picture, right, they're purple ones at the top and the blue ones at the bottom. Mine's the other way round. I hope this is long enough to fit, because that would be a shame, wouldn't it? Then they say also put the switch in. Any preference on which way up the switch goes? Up to the top? Or do you go up to the top or up to the bottom? You didn't get a washer, but you got heat shrink. Oh, cool. So, do you want it that way up? Or that way up? Do I have anything else with a rocker switch? I think that way. Yeah, I think that way. I'm going to go with that way. Do I have anything else that has a rocker switch on it, which I can compare it to? That does, but it's sideways. That's no bloody use, is it? That's a push button. That's a little side flipping. No. All right, I'll just go with my gut, which is that way around. Going with it like that, yeah. All right, that's in. Lovely. Don't I want to solder things onto that though? I don't know. Right. Next. Oh look. Solder the longer wire. Which is the longer wire? What are you talking about? Solder the longer wire. Solder the longer wire? It says for say. Next step, for a better solder joint, blah 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 blah. Solder 2 wires to the lugs as shown. Right. Doesn't say anything about their length, although one of them in the picture is longer. I thought that was accidental. Now fix the socket into the case, tighten, insert the power thing, solder the longer wire to the bottom lug of the switch. What? Then put a heat shrink tube on the shorter wire and solder it to the top lug of the switch. But what? Longer wire is positive, Peter. What? Okay. Alright, so it's going to matter which way round I put this switch in, basically, because that's going to matter because of these wires being connected to it. So it matters which way up I put it. I don't know which way up to put it. It hasn't said which way up to put it. But from the picture, this picture here, I can see that it looks like this, that there's 2 at the bottom and then a space at the top. That's what I've got. Now this nonsense about longer wires and shorter wires doesn't seem to make any sense, because the longer wire is the blue one, and in the picture he's not done anything with the longer wire. What he's done is taken the purple wire and plug that onto the top. And he's taken a different wire and soldered that onto there. What are you talking about? Use a lighter? Good Lord. This is nuts. And then he changes the wire completely. Oh, for crying out loud. Alright, just get a grip, everyone. Switch orientation doesn't matter. Well, it does if I want the 1 and the 0 to mean anything, basically, yeah? So, 20-minute countdown. We're not going to make it, are we? Does the switch only have 2 lugs? Yes. So it doesn't matter which lug you use. I know, but it does because of the 1 and the 0 thing, yeah? Your blue is, and your blue is negative, and your purple is positive. That goes to the switch. Now it's DC we're talking about, Peter. It's DC. But I mean, if I'm following what the photograph is telling me, and assuming that it's the same thing, I mean that purple one is the one from the center, and that purple one is going to the top of the switch. That we know. Yeah? How'd you get a lighter in there, honestly? So that I can do. When we come down here, it's all changed, but you can see what's going on. So that's okay. These instructions are, unfortunately, Moritz, are not very clear. Not very clear. Sorry, mate. Solder the longer wire to the bottom lug of the switch. What longer wire? You're not making any sense. So, I mean, I'm assuming that perhaps these instructions are referring to something which should be in the pack. Maybe there should be wire in the pack. There isn't in mine, but then I got mine ahead of release. So they might have changed that slightly. You know, who knows? Anyway, I'm going to use slightly fatter heat shrink because of this big bit here it's got to fit over. I'm going to cut that in half. I'm going to stop belly aching about it and just attempt to do what it says. So, no, I don't want... What is that? Somehow I've brought up Microsoft Teams. That's a good one. Thank you for that. So, this needs to be soldered onto here. Got it. But maybe before I put this top one on, I should solder the bottom one on. So maybe that's what it's referring to, that I just need to have another piece of wire, not a longer wire, just another piece of wire, soldered onto the bottom of that switch. So I'm going to do it in purple again like it is on there, even though it changes later. Come on, keep at it. There's no point getting into a quagmire over the over the instructions. Okay, got a bit off. Oh, I should get some wire strippers. I really should. Okay, got another bit off. Right, so bit of heat shrink. Let's try to get this through here. I really should have done this before we plugged the switch in kind of my thinking of it now. Okay. Try not to melt anything else while I'm at it. Okay, good. Good. Now I didn't scrape the lugs. Force that on there. Good. So it's not the blue one. The blue one is the outside. It's the positive one, which is this one. which is going to come into here. Heat that up. Good. Get this heat shrink round. Like that. Great stuff. Right, I don't have a lighter. I haven't smoked for... Oh, see, that's just melting it. I need a lighter. I haven't smoked for 15 years? I don't know. Can't remember. Anyway. It will be good enough. It will be shrunk enough just to protect it a little bit. I have no fire. That'll do. Whatever. Just so that they don't touch each other. Right, so I've now got two cables coming off there, which seem to match what's in the photograph. So all the longer wires at the bottom. No, anyway, put the heat shrink. Yeah, okay. Put the heat shrink tube on the shorter wire. He's talking about these two wires like that means anything. So anyway, now use a lighter, yeah, to heat the tube so they shrink around the switch lugs. All right, done enough of that, I think. Insert the PSU board. Right, now it's getting exciting. Two purple wires soldered onto the same lug. No. No, top and bottom, not the same lug. Top and bottom. Top and bottom, see that? So the one from the power cable is going into the top. And I've got this bottom one just coming off, just like it is in the picture. Yeah? You with me? You feel me? Good, good. So this goes down here. Fix it with 8 screws. Is it alright if I put the wires in first? Connect the 2 wires to socket XS1, one at the top. Mind the polarity. The wire from the switch goes to V+. Okay. The wire from the side lug goes to ground. Yes, that makes sense because that's what they are. So I'm going to undo these first. Oh, they're already undone. Okay. So I'm going to plug these in before I screw everything in because that's just, I think that's easier. Alright, so put that in there. That one from there. Screw that down. This one is the ground, goes to ground. See that all right on there? Good. Keeping those nicely apart. Now there should be a whole bunch of screws somewhere then. There we go. What sort of screws? I need these sorts of screws, okay. Don't leave bare wires showing in case of shorts. Yeah. They're alright, they're far enough apart. Besides, Mr. Moritz didn't say anything about it, so, you know. But yeah, one could cut these wires down a little bit so it goes all the way up to the shoulder. But are they ever going to short out? Could they possibly cross the streams? Yeah, they could. So why don't I do that? That's going to be the answer, isn't it? So let's get these in. So all of my efforts of doing it before I screwed the bloody thing in, which is a good idea that I'm now going to undo. Right, that's in. That's good. So it's been suggested that I really need to not have any bare wire showing. So in that case, I'm going to trim this down rather than trying to put heat shrink up to the end, which is just weird. I'm going to cut that down by half so that when I bend that in there, it'll go all the way up to the shroud. Shroud, is that the right word? I don't know. Put that in there. Cool. I'll do the same on the other wire, just for safety's sake. Good. Right. We're in. We suspect. It's easier to fold the fold the wire instead of trimming the wire. Okay. I just stuffed them in there. Yeah, I'm in with that. Congratulations! Yay! Yay! Completed the assembly of the DIY case. Connect the adapter, flip the switch, both LEDs will light up. Awesome. So let's do that. Let's do that bit. So I need a plug. There's a plug over there. This is the right one, isn't it? Well, it fits all right. So yeah, let's stick that in there. Put it to off. Now, of course, everything goes away. I am sorry, and we'll pick this up again tomorrow night. But hopefully, it won't just blow everything up. Let's plug that in over here. Turn it on at the wall. Okay, so far so good. Turn it on at the switch. Are we ready? Fingers crossed. Okay. Oh! Flippin' heck, that was bright. We got it right. We got it right. Oh my goodness. We got it right. So if I put my tongue on here, then I should be able to tell if there's power. Is that the idea? Look at that. I mean, it was a very elaborate way of turning on a couple of LEDs, but heck, we did it. Both LEDs should light up. If they do, measure the voltage between the ground pins on the Eurorack power connector and the -12. Ground, okay, and -12. I can do that, I think. So measure the what? Voltage. DC voltage. Alright, it's between, let me do this in a place where you can see, between ground and -12. So ground seems to be in the middle. Oh, fuck! Well, I shorted something, that's for sure. I think we got away with it. Okay, let's try to be a little bit more careful. So, I don't quite understand that. Ground. How do you do it steady enough? -12 is the bottom right one, yeah? -12. Right. Then continue with plus 12. If these are okay, you can start putting your things in. So plus 12 is what? Is pin 1, 2, 3, 4. Pin 4 and ground. So 1, 2, 3, 4. This one. And ground. Positive 12 volts. So yeah, that worked then. Cool. If the readings are good, you can start populating with the newly built Eurorack modules. Now, is it usually good to turn the power off when you plug in modules, or not? That's all we get. That's all we get from there. So let's put our modules in. Now, sadly, I don't think they have any flashing lights, do they? Okay. No, so I'm going to have to plug it into something that we can hear. That's going to be troublesome. I don't have anything set up just now. Okay, I'll turn off my fan. That's a relief. Look at that, 3 minutes. 3 minutes. Okay, that's that one. And that one. So where do you think they go? Is it going to matter? I mean, I'm going to imagine the VCO goes over here, but then doesn't an LFO go next to the before the VCO? So it's going to fit there. Does it matter at this point? Of course it matters. Everything matters. So let me go to Erica Synths page and see if there's a picture of the whole gang. Yeah, it could be. Sequencer, he reckons, first. Then VCO. So VCO in over here. So let's plug. Everything's turned off, isn't it? Yeah, lights are off. So plug this in there. Now these holes might not be nearly sized. In which case did they come with screws? Okay. Oh, now my knurlies I think are just too big, but I think with a little bit of persuasion, like a screwdriver, they might take. Because they don't come with screws. My case didn't come with any screws, I don't think. Sorry, camera. Now, of course, I could just be ruining the whole thing, and that would be a shame. Use masking tape instead of screws. Right. Yeah, no, those are going in. Just a little bit on the self-tapping side. Okay, I'm going to go over a little bit. I just would like to get some sound through to know that these are powered. VCA, so there's fold, VCF, dual VCA goes in here. Folder, VCA, there. It is slightly weird because it's not a rail that these things are floating about the place. That is slightly strange. Now the other thing, got these little feet, I think. To put on the bottom. I'll worry about that in a minute. So let's turn this on again. Okay, looking good. Sound, I need to get something out. Cable long enough. Yeah, no, not a sausage. There we go. Good. Excellent. Excellent. That's pretty good, that. This is all over the place now. What did I do? Did I bash it or something? I don't remember. So there we go, the case and power supply then. Well, that was a bit of fun. We had some lark going on in there with all sorts of stuff. Did we not? I mean, it's looking great. It's going to look great with all those modules in, you know. It really is. I'm really pleased with that. It wasn't difficult. There was just some some little bits of lack of clarity, like there has been really all the way along. I mean, and in many ways that's to be expected. I mean, my experience of dealing with manuals and build guides, because I mean, I'm just obsessed with the clarity of these things. I just am. I can't help myself. But what I mean, I'm trying to use that to an advantage, in as much as if I can point out the things that are wrong, then other people won't go wrong. That's my vibe. I'm not trying to go, oh, you know, this is rubbish or that's rubbish, or you should be doing better at this, that, and the other. That's not really what it's about. But of course, those things. But the idea is that, excuse me, I bellyache about these things in order to highlight them so that less people have trouble, so that we get through these things. Do you see what I mean? So with this one in particular, and with all manuals, it's always hard for someone who's writing a manual about something that they know in depth. It's really hard to put yourself in the position of a person reading it for the first time. It's really very hard to do that. So Moritz has done a great job on this. He already teaches this stuff really, really well, and whatever problems you run into along the way, all of them you can get over. You can get over them and you can get through them. But hopefully in my demonstration of what goes on, I can just help that be that little bit smoother and less confusing and stressful for people. Perhaps because I'm sitting here having all of that stress and frustration on your behalf, if you see what I mean. So I can't remember now which way around the LEDs went, but it would have been so useful to have that specified in the build guide. The business about the wires he's talking about is very unclear. Don't know what he's talking about. So I think you could really do with redoing the whole soldering of that switch thing. Tell us which way up to put the switch. Tell us what you're talking about the long and short wires. What does that refer to? And just make it a little bit clearer. That would be enormously helpful. Other than that, good. We're cooking on gas. See, I want to turn this over to put the feet on. If I do that, I'm going to... I'm sure I can do it one way or another. Let's just get this finished. I'm assuming this comes off here and it's sticky underneath, is it? Don't know. I'm going to say that it is. Yeah, it seems to be. Right, so let's give it a corner. I just stuck it on just like that. Not measuring it or mucking about. So any last questions, quick, before we call it a night? Oh, I was going to say about the envelopes, because the envelopes are next. They've already been out there, and my plan at the moment is to do that next Wednesday, but it'll probably be the Thursday, because I imagine it's going to be a long one again. Not that this wasn't a long one. So pencil us in for next Wednesday, same again, 7:30. See if we can tackle the breadboarding of an envelope, and then probably the Thursday for the actual soldering of the kit, or two kits. Probably only do the one kit, you could do the other one in your own time. But the idea with the envelopes is to get two, because you need one for the filter and one for the VCA. And we'll do that next Wednesday night, see where we get to. Oh, that's not straight. Good. It's upside down. Oh, good. Lovely. Lovely job. So there we go. All done. All done. Yes. Crashed through as normal. Great stuff. Thanks for spending some time with me this evening putting this together. I hope that was useful to anybody out there who's building this yourself. See you next week, hopefully, for the envelopes. But I'll confirm it during the week. Probably over the weekend by putting up a YouTube shortcut to the forthcoming thing. So I can't absolutely guarantee it'll be next Wednesday, but that's the plan in my head at the moment. But we'll see how we go, because I am also about to hit a Molten monthly, and of course I haven't updated the iTent screen thing yet. No, I've got to fit that in somewhere. But yeah, so there we go. Anyway, thanks very much for your company. I hope that was helpful. I've said that already, so I'll just say good night and go and make some tunes.